economics. So far we have been discussing about presentation of data. Right, we are in statistics for economics and we have completed discussing about what is economics, what is statistics and the relationship between both. Then we have spoken about the first step in statistical analysis, which is collection of data. We have discussed the sources of data, modes, methods and all those things. Later on we moved on to the organization of data. Why do we have to organize the data? Because the raw data, the data that we collect, let it be primary or secondary, it is called as a raw data, and it is very difficult for us to draw out information from the raw data. That is why we need to classify the data and take it for further analysis. Once you have done the collection of data and the organization of data, the next thing is that you present it in a right way. Right, presentation of data means what? Showing it, presenting it in a readable form is called as a presentation of data. So far we have discussed what are the three forms of presentation of data. We have the textual presentation, okay, textual or descriptive presentation where data is given as text. Point number 1, that is the first form. When we discuss the second form, it is actually called the tabular presentation. What is it called? It is called the tabular presentation where the data is presented in form of a table. Before you go for a tabular presentation, you need to classify the data into spatial classification or temporal or chronological classification, quantitative classification and qualitative classification. We have discussed this even in chapter number 3, which was organization of data. Then we went on to discuss about how do you tabulate a data, what are the various parts of a table that you need to keep it in your mind to present your data in the right way, because tabular presentation means what are the parts that should be there. We should know that, and only we can present it in the right format. That is why we discussed about what are the various parts of a table. In the previous video session, we have started discussing about the third form of presentation of data, which is called the diagrammatic presentation of data. Compared to the other two techniques, this is found to be very quickest and very easiest, because once you see a diagram, it is easy for us to understand how it is presented, what data is presented in that we can understand. Out of that, even again, this is further classified into 3. Diagrammatic presentation is further classified into 3. Geometric diagrams. Okay, then we have frequency diagrams and arithmetic line graph. Geometric diagram is further divided into bar diagrams and bar diagrams and pie charts, right? So when we talk about the diagrammatic presentation, we have 3 forms. First one is called as what? We call it the geometric diagram. And second, we have the frequency diagram. And finally, we have the arithmetic line graph. Right, children, even for us, for understanding a topic, if I put it in a diagrammatic presentation, easy for us to understand. Even this is a presentation, right? Instead of giving you it in a textual format, I give it in this format so that it is easy for you to understand the classification. So talking about geometry multiply it by 3.60. Right. How do you get this 3.6 degree? When you divide 360 degree by 100, you will get this 3.6 degree. How you are calculating it? You are calculating that 100 equal parts. You are calculating the circle into 100 equal parts. So what is given here? It is also a component diagram. What did we discuss first? First thing itself, it is a component diagram. A component bar will have a rectangular bar which has components. A pie diagram will have components in shape of a pie, parts of a pie. Right. So this is a circle whose area is divided among the components, various components. So what kind of data you use for a component bar diagram? Similar data only we are going to use for this pie diagram also. So it is also called what? Pie chart. Usually this is a common term that we have used, pie chart. More than pie diagram, we use a pie chart. Even in your junior classes, when middle school, when we were discussing about statistics, you would have drawn a pie chart. Okay, it's easy to understand. So how will you draw? From the center, and this is the center of the circle, right? From the center to the circumference, you will draw, you will mark the proportions. Okay, it usually are not drawn with absolute values of a category. When you say 220 students, you will not, how will you measure the 220? So absolute values are not taken into account here. So for that, what do? You need to convert them into percentage. Whatever data is given, you need to convert them into percentage. Only then you can proceed to the next step. Right, children? That is what we are doing here. Here what are we doing? You are converting the actual data of each category into percentage. And a circle in a pie chart, irrespective of its value of radius, is thought of having 100 equal parts of 3.6 degree. We don't know how many parts are there. We just assume that it has 100 equal parts, and that is why we find it to be 360 degree divided by 100. You will get 3.6 degree. So once you find the percentage, you need to calculate the next, the angle that you are going to measure with 3 point, multiplying it by 3.6 degree. So we have a table where it is actually multiplied, you have taken the percentage and everything. So for example, what it is, it may be interesting to note that data represented by a component bar diagram can also be represented by a pie diagram. That is what we said already, that whatever data is represented using a component diagram, the same data can be used to represent a pie diagram. So in the example that has been given for you, the marginal workers population is 12. Then 36, 73. How they have done? So let's take 12, 36 and 73. When you add it, you will get a value of 1 or 2, and they convert it into percentage. 9.9, right? 20.8 and 60.3. And you total it, how much can be represented or presented using a multiple bar diagram. A component bar diagram lets you to find the difference and connect it with the relationship between each integral part given there. A pie diagram is similar to a component bar diagram. Only thing is that a component bar diagram will be in the shape of rectangular bars, whereas a pie diagram takes up the shape of a circle. A circular form is used here, and then it is proceeded with the next step. Right, children? So these are the pie diagram. What you have to remember? You have to remember that the actual value is not represented. It is converted into percentage value, and that percentage value is converted into angular component. Then only it can be marked there. Right, children? So what is the next thing that we are going to discuss? We are going to move on to the next kind, which is going to be the frequency diagrams. So under frequency diagram, we are going to talk about an histogram. We are going to talk about a frequency polygon. We are going to talk about a frequency curve, and then finally we are going to discuss what is meant by a OQ. Okay. These are the 4 kinds of frequency diagrams that we are going to discuss now. So what are we going to start with? We are going to talk about frequency diagram. As the name says, it is for frequency data. Okay, it is going to be used for frequency type of data. Talking about bar diagrams, for which type of data is it applicable? For both frequency as well as non-frequency, but mostly it goes for non-frequency data. Like here we are going to have a class, we are going to have a class with everything. So generally data in the form of grouped frequency. So data with grouped frequency are going to be represented here. Under this, what are the various kinds we have? Histogram, frequency polygon, frequency curve, and finally OQ. So we are going to start with the histogram. What is the first diagram that we are going to talk about? Histogram, and it is a 2-dimensional diagram. Okay, we are going to have a 2-dimensional diagram. It is a set of rectangles with base as the intervals between class areas, class boundaries, that is class width. Okay, the classroom is upper class and the lower class limit are kept as the intervals, and they are in the x-axis. What would be in the y-axis? The frequency will be marked in the y-axis. Fine, it is what shape? Rectangular shape, rectangles with base as the intervals between class width. Okay, and what is the frequency is given in the y-axis with the areas proportional to it. So if the class intervals are of equal width, which they generally are, the area of rectangles are proportional to their respective frequency. So what is it? It is going to be rectangular and it is going to be equal sized, right? So it is going to be of equal size. Usually what do we have? Even if we have unequal sized things, if we have a gap, we know how to adjust that gap. Excuse me. We have discussed in the previous class that in the previous chapter that how to adjust the gap between the class intervals. Do you remember, children? By finding the gap, dividing it by 2, adding it and deducting it from the upper class and lower class limits, you can have a continuous frequency. Similarly, we are going to do it and then we are going to present it in the histogram, right? For graphical representation of such data, height for each area of rectangle is the quotient of height and previous chapter when we have discussed about the frequency distribution, we discussed in one such examples when too many data are dealt with one particular class that was given as unequal sized. In that case, you need to calculate it in the right way that the width matches with the height. Okay, the width should match with the height. And since histograms are rectangles, a line parallel to the baseline and of the same of the magnitude is to be drawn at a vertical distance equal to frequency of the class interval. Whichever is the highest class interval, highest frequency given, it should be equally drawn. Since it is rectangular, you should have this x-axis to be equal to the y-axis. Then only equally you will have. If you are having 10 values down, then you should have 10 values in y-axis also. Whether you use it or not is secondary. But you should have equal number of, try to have equal widths. Because every frequency should be covered. Okay, since I don't have place, I have stopped. But when I talk about the 95 to 99, that is 94.5 to 99.5, I don't have place to mark it. So I will leave the frequency. No. So I have to plan my place properly and I have to present it neatly. Right, children? A histogram looks similar to a bar diagram, but there are more differences than similarities between these two. It looks like a bar diagram. Which looks like a bar diagram. The histogram might look like a bar diagram, but histogram is different from a bar diagram. How are they different? What are the differences here? The first thing is that the spacing and the width or the area of bars are all arbitrary. It is the height and not the width or the area of the bar that really matters. What are we going to talk about? We are going to talk about the height. The frequency matters a lot. We are not talking about the width here. And what is one more thing? A single vertical line could have served the same purpose as a bar of same width. Moreover, in histogram, more space is left between two rectangles. One, the biggest difference is that in a bar diagram, we will have separate bars. Okay? You can have same class width down, also the same width should be there, same equi-spaced we saw, right? It should be equally spaced between each bar, fine, but still, they are not connected to each other like histogram. In histogram, we draw the bars connected with each other, touching each other, whereas in a bar diagram, they don't have relationship with one another. Right, and one more important thing about a bar diagram is that you can simply have drawn one single, a vertical line instead of going with drawing a bar. There is no meaning because you are not mentioning the width here. Here we need width. Histogram we need the width because it mentions the class limit. Right, so you are talking about this, but in a bar diagram, when you have it, simply you would have marked here 14 means 14, 12 means 12, 10 means 10. Single line, what is the biggest difference? Single line and a bar, is there any difference? No. But in histogram, it is very difficult to have it in the shape of rectangular bar because it talks about the width. Whereas in bar diagram, we don't mind about the width, we talk only about the height. Here, both are important. In histogram, the height also is important, the width also is equally important because it mentions the class different. The class width is mentioned here. Right, children? So, those are the differences between an histogram and a bar diagram. Okay, what else? The width in a histogram is important as a height. As I said already, it is very important because it talks about the class limit, the upper class limit and the lower class limit is marked. And what else? We can have a bar diagram both for discrete and continuous variable. Already we have discussed this. But what happens with an histogram? You have to draw it only for a continuous variable because it touches each other. That is why we did an adjustment also here. Right. Here there is no need for In histogram, you can do it only for a continuous variable. Okay, it can be done only for what? Only for a continuous variable. You cannot go for the other kind. Okay, so that is the special thing about histogram. And what is one more thing? It can help you to find the mode. Mean, median, mode. Right, so it helps you to find the mode. Histogram also gives value of mode of the frequency distribution graphically as shown in figure and the x coordinate. So what happens? You need to find the mode. How do you find the mode? You have a calculation for that, right? Same way here we are going to find it or mark it graphically. Whichever the tallest, the highest frequency is there, right? You're going to take that, okay, and you're going to point out when two bars are meeting like this. Okay, the place where it meets and where it meets with the next bar is marked. Okay, so this meeting point is there, right? That is considered to be the mode. Whatever value is found out here, that is called as the mode. When you have the tallest bar, you need to match it to the next two bars, you know, the left side and right side, and wherever those points intersect, that point is called as a mode. Right, so what are the various things we have discussed, children? We have spoken about what is meant by a pie diagram, and then we started discussing frequency diagram. In frequency diagram, the first diagram that we have discussed today is histogram. Histogram is used especially for continuous variables, and frequency diagram itself is used for data which has grouped frequency. And then what else we have? It is a two-dimensional diagram, and the x-axis is the class width and the y-axis is marked with the frequency. If the data given is not continuous, we should do the adjustment in the class interval. We know how to do this adjustment, right? Based on that, we need to calculate it and we have to take it to the next step. Right, children? You have to make the adjustment and then you have to mark it continuously. Continuous variables only can be represented through an histogram. So you have to mark that in the x-axis, and the frequency limit will be marked in the y-axis. The width is very, very important. Unlike an histogram, unlike a bar diagram, in histogram the width of the rectangle bar is taken into account because it marks the width. The height marks the frequency and the width marks the class limits. Right, children? So both are important here. And you can find the mode also. So you can just find the tallest bar, the highest frequency limit. From that you have to find the mode in the center. The value, how both the lines intersects, that particular point will be marked as mode. Right. What is the next thing that we are going to discuss? We are going to talk about frequency polygon. What are we going to talk about, children? We are going to talk about frequency polygon. And it is a plane bounded by straight lines, usually 4 or more lines. How is a frequency polygon done? It is usually done by a straight line. Okay, a straight line that bounds. How it is going to bound only we are going to discuss. What is the next thing that we are going to talk about in frequency diagram? We have already discussed about histogram. Now we are going to start discussing about frequency polygon. So what are the various things, children? Geometric diagram, frequency diagram, and what is the one more? The arithmetic line graph. These are the three types in the diagrammatic presentation. Remember, in presentation of data, we have three techniques or three methods. They are called as textual presentation, tabular presentation, presentation and diagrammatic presentation. Textual presentation is also called as descriptive presentation. Data is presented as text. When data is very limited, you can go for textual presentation. Tabular presentation, it is very easy to understand because it is given in table. You can easily draw out information. We have discussed what are the various parts of a table, what are the essential parts of a table, and the diagrammatic representation, which is the third method of presentation of data. We have again subdivided into geometric diagram, frequency diagram, and the arithmetic line graph. In geometric diagram, we spoke about bar diagrams and pie diagrams. We have started discussing frequency diagrams. In that, we have discussed what is meant by histogram and how is it different from a bar graph, bar chart. Okay, a bar diagram. How is it different from a bar diagram? What are we going to discuss next? We are going to talk about frequency polygon. When are we going to discuss about frequency polygon? Let us do it in the next video session because I don't want you to get confused with the frequency diagram that already we have discussed histogram. So we will be discussing frequency polygon and frequency curve and octave in the next video session, so that we can take time to understand the concepts that we have discussed so far. Draw, what is the one work I have given you children? You have to draw a pie diagram